me, Michelle. Today's video is going to be on excess and limiting reactants.
So hello everyone, today we'll be taking a close look at yield calculations with reactants in excess. To start off with, let's think about a reaction between iron and sulfur. So we'll get the reaction between iron and sulfur that produces iron 2 sulfide. Here's the iron here, and we'll have the sulfur, and these react to form the iron 2 sulfide. Now let's start with 4.68 grams of iron and 2.88 grams of sulfur and try and find out a couple things. First of all, what mass of iron 2 sulfide will be produced? And second, how much of whatever is left over will be left over? In order to do this calculation, we first have to start with a yield calculation, and we'll start from the perspective of the iron, assuming all the iron is used up. So here we have the 4.68 grams of iron. Here's the molar mass of iron. Not only the mole ratio between the iron that's used up and the iron sulfide that's produced. Finally, the molar mass of iron sulfide. Don't forget here the mole ratio between mole ratio of iron and iron sulfide. Yeah, the molar mass of iron sulfide, 87.9 grams, and this gives us 7.37 grams of iron 2 sulfide, presuming all the iron is consumed. Okay, now we take a look at it from the point of view of the sulfur. Start with a 2.88 grams of sulfur. Now the molar mass of sulfur, 32.1 grams. Mole ratio between sulfur and the iron sulfide, and that's 1:1, as you can see right here. And then we'll use the same molar mass of iron 2 sulfide at the end. So just use that term over again, check all the units are good. In fact, they all do work out, and we wind up with, at the end, grams of iron 2 sulfide as 7.89 grams. So this value presumes that all the sulfur is consumed. Okay. There's a couple conclusions here. First of all, the smaller yield is the actual yield, which makes the iron our limiting reactant, which also tells the sulfur is the excess reactant. Now, what about the 7.89 grams over here of iron sulfide? This is not a real yield. Do not calculate with this value. Okay, this didn't actually happen, so we can't do any calculations based on something that's not actually real. So now to determine the quantity of the excess reactant that's left over, the excess reactant is sulfur in our case. And to do so, let's take a hint from an 80s rapper. Little throwback here, and see if we can get something from this fine fellow. He said, "Ice, ice, baby." Well, what do you mean by ice, Mr. Bonin? I mean the initial amount minus the consumed amount will be the excess amount. And there is your ice. So whenever we need to get quantities of excess reactants, we'll just use this idea. Here we'll start with the initial mass of sulfur, the excess reactant. How much do you start off with? Then we'll compute how much mass of sulfur was consumed by the reaction. We'll have to calculate that. And finally, subtracting these two, we'll get the mass of sulfur that's left over at the end. So the initial mass of sulfur here, there's ice, ice. Again, the initial mass was 2.88 grams. As initially, now to find out how much was consumed, we'll just do a simple stoichiometry calculation here, starting always with the limiting reactant, in our case, 4.68 grams of iron. Now, again, use from above the molar mass of iron. It's 55.8 grams. And this time we'll use the molar ratio between iron and sulfur from one reactant to another. On the bottom, we'll have 1 mole of iron. On the top, 1 mole of sulfur. And then at the end here, of course, we'll use the molar mass of sulfur. Again, one more thing you can recycle from the calculations that are above. It's 32.1 grams. Anyway, compute this and get 2.69 grams of sulfur consumed by the reaction. Check the units. Yes, it's good. And this is the mass of sulfur consumed by the reaction. Above, we had the mass of sulfur we started with. Subtracting these two, we get 0.19 grams of sulfur left over in excess after the end of the reaction is complete. So this strategy will work whenever you're concerned with quantities of excess reactants. Here are the essential ideas, okay? The essential ideas, the things you shouldn't forget. The first essential idea is you need to calculate a yield from each reactant. So do a yield calculation from each reactant. There's our first idea. Second idea, the smallest yield is the predicted yield. And that one comes from the limiting reactant. Why? Of course, because by the time you've made that much, you've used all that reactant up and you can't make any more. Consequently, any yields over that are impossible. And the last idea, if we care about the quantity of excess reactants left over, if that matters to us, then use ice. Ice, baby. Anyway, that's about it for now. Certainly glad to have all of you here, and do have a look for more on this topic. Thanks everyone, and see you soon. Please do, really honestly, have a look at the next 2 videos in the playlist for more, and stay tuned for our next lesson, lesson 19, percentage purity and yield.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe.